Hey everyone, welcome to the Swift Fundamental series. In this series, we'll go through the Swift Apple book chapter by chapter and try to understand the basics of the language. I recently started building iOS apps and I realized that I don't have a good grasp of the fundamentals, and that really held me back. So in this series, we'll go through each chapter and learn what the details of the language are. And hopefully by doing this, we won't ship too many stupid bugs. So without further ado, let's just dive in. One of the first things you want to do, besides print hello world, is to store data, reference it later, and move it around. Swift gives us two ways that you can do this: variables and constants. Okay, let's look at some real code in our Xcode playground. First, let's define a variable called favColor and set it to an initial value of red. So var favColor equals red. Here, the var keyword tells the Swift compiler that favColor is a variable, which means it varies, it can change its value, and we're setting it to an initial value of red. So, like I said, variables can change their values, so let's try to change it. So favColor equals blue, and let's try to run it. While that's happening, let's just set some more favColors. Brown, or favColor equals black. I'm just going to minimize this for now. So here, when we ran the line here, we see that favColor was initially red and then it changed to blue. If we run it here, we see that now it's changed to brown and now it's changed to black. So you kind of get the idea. Once you set a variable, you can change it over time. A constant, however, cannot be changed. So let's see what I mean by setting a constant called iColor to brown. So let iColor equals brown, and let's try to change it. iColor equals blue. All right, let's try to run it at this line. Okay, so the Swift compiler is complaining loudly. iColor is a constant, and how do we know it's a constant? There's this let keyword before iColor that tells Swift compiler and us that it's a constant. A constant cannot be changed. It's set. So once you set iColor to brown, you cannot change it to blue, which is why it's complaining right here. So yeah, you get the idea. A variable can change over time. A constant cannot. Okay, so usually you would define variables and constants in different lines. So you'd say something like var, I don't know, var name equals Priyanka, and then maybe let age equals unknown. I'm not gonna tell you my age. So yeah, you would define different variables and constants in different lines like this. However, sometimes for readability, you are writing code so that other people can read it. It would make more sense to put it on the same line. So imagine you're defining 3 points in a coordinate space, x, y, and z. It would be nice to see on one line to see what's going on. So you could say something like var x equals 0, y equals 0, and z equals 0. So if I try to print x, y, and z, it'll tell us what's going on here. X, y, z, yep, 0, 0, 0. So unlike other languages, Swift doesn't require us to type a semicolon after each statement. Let's define a constant, right? Let's say let cat equals, let's say cat is that emoji, right? In other languages, you would have to put a semicolon at the end before you say let dog equals dog, right? So in Swift, you don't actually have to do that unless you're writing these two different statements on the same line. So here, we could remove this and then everything would be fine. But imagine, I don't know why, but you would want to write this on the same line. You could do something like this and it would be totally fine. So if I try to print cat and if I try to print dog and print at this point, you can see there's a cat and dog. So yeah. So now that we learned how to create variables and constants, let's look at what options you have to name them. You can pretty much name them anything you want. Any English alphabet letter, any Unicode character, pretty much anything. So for example, you could say something like let greeting equals hi. You could say let pi equals 3.14159. You could pick a Chinese character, something like this, and name it that. You could even name your constants and variables emojis. So you could say something like emoji dog cow equals dog cow. So if you do run these, you do see the outputs. I would suggest not naming your variables something like this because it would be really hard to refer back to. Imagine you're going to a colleague and saying, oh, pi is stored in some sort of pi symbol, or let's say the word dog cow is stored in an emoji of a dog and a cow. It's like super creative, but it's also very cumbersome to deal with. So I wouldn't even do that. I would stick to English letters. There are some exceptions though. You can't name your variables anything. Here are the rules. You cannot have any white space characters in your variables and constants. So for example, you can't say something like let h space I equals h space I. Yeah, you'll see that. Yeah, you'll see that it doesn't make any sense. It's complaining. You can't name your variables or constants any mathematical symbols. So let's say you say something like let plus equals plus. It'll complain again. Yep. You can't use arrows or anything like that. You can't start your variable or constant with a number. Let one apple equals one apple, for example. Again, it'll complain. However, you can say this works, apple 1. You can use a number in between or after any character. Okay, yeah, it's complaining because this is not working. All right, there we go. Also, you cannot use reserved Swift words. So that means something like var or let. I think these are the only two you've seen so far, but there's other ones like if or for. So let's say you can't say var let equals let. You know, it'll probably complain here too. Yeah, there you go. However, if you have no other choice and you absolutely have no other choice at all, you can use backticks to fix this. And say, let's do something like print backtick, let. This works. I would say don't even, like, why would you even do this? Just use it. Use your brain and try to think of another creative way to name your variables and constants. So, yep, there we go. This is the different options that you have to name your variables and constants. Okay, now that we know what we can name our variables and constants, let's see what you can store in them. A type tells us what kind of data that we're storing. This probably won't make too much sense right now, but soon it will, I promise. One kind of type that you can store in a variable and constant is an integer. So you could say something like var age equals 10, and you might have learned that an integer is, a whole number. It's a number that doesn't have a decimal point, it's not a fraction. So you could store any sort of integers. Let's say let number of continents equals 7. Yeah, so an integer is a whole number and you can store that. A double is a fraction, right? It has a decimal point. So let's say height. Var height equals 5 feet and 3 inches. We could say var pi equals 3.14159. A double is a fraction that you can store. You could also store a string, which we've been looking at before. So var company name equals apple, or let name of phone equals iPhone 6s. So a string is like a word or a sentence. It's defined by consecutive characters put together. A Boolean is a true or false value. So you could say something like var is sky blue equals true, var is earth flat equals false. So yeah, a boolean is a true or false value. A tuple looks something like this. Var point equals 0, 0. So it's a collection of two different values that sort of act as one. You could store structures, you could store classes, you could store functions, and you could store many, many more. I'll get into more detail as we go on. But for now, just know that you can store a number of different types in your variables and constants. Now that we kind of understand what we can store in our variables and constants, let's look at what types you can store in them and how you can change them. Swift is a type-safe language, which means that the language helps you to be clear about the types of values your code can and cannot work with. So if you define a variable as a certain type, you can't change it later to store a value of another type. Let's look at an example. So imagine you say something like var number of continents equals 7 continents. And then later you go back and then you see, oh, this is kind of redundant. You know, I could just say something like number of continents equals 7. This makes more sense. And you try to run it. But the Swift compiler complains loudly. It says, cannot assign value of type int to type string. So what's going on here? Here in the first line, when you say var number of continents equals 7 continents, and you initialize it as 7 continents with the double quotes, you're saying from now on, number of continents will always be of type string. So when you're changing it here to a type int, Swift gets confused and complains loudly. You can't do this in Swift. So in this example, if you didn't know what strings look like, we now know that strings look like this double quote thing and it looks kind of like this, like a word. But imagine you just didn't know this, right? You would have a hard time identifying the type that this variable is supposed to be. Type annotations can help with this. So when you say var number of continents equals 7 continents, rather than saying just this, you can say, okay, reader, this is going to be a string. This here is a type annotation. A type annotation tells us that this variable number of continents is going to be a string forever and ever, and we can only change it to any string. So we could say number of continents equals, I don't know, like imagine 2 continents collided. Okay, 6 continents. Great. We can change it, but we can only change it to a string. And we're clear about that by using a type annotation. To define a type for multiple variables, we can do something like this. So imagine we have a point in a coordinate space. We could say something like var x, y, and z is a double. And this is great, right? And then we could say x is going to be, I don't know, 1.2. Y is going to be 2.4 and Z is going to be 4.8. Great. So type annotations help us actually see and define what kinds of types our variables and constants are going to be. So in the beginning of this section, we said that we saw that we don't actually need to have this type annotation, right? We could just remove it and it would be totally fine. Swift would still compile, no issues. But how does Swift know that this variable is a string? When we first initialized this variable, we initialized it as a string. So Swift is going to be like, okay, once you initialize it as a certain type, from here on forth, it's going to be that certain type. So if you say something like var age equals 22, here we see that we don't have to say age is an integer, right? We could say that, but we don't have to. Why? Once you initialize age as 22, Swift will infer the type of this variable as an integer. What happens, however, if you use an integer with a double? So let's say pi equals 3 plus 0.14159. 3 is an integer, 0.14159 is a double, right? But what is the type of pi? Let's see. Type of pi, we run it, we see that it's a double. So when you combine an integer with a double, Swift will infer the type of that variable as a double. So yeah, there you go. I hope this makes sense. Before I let you go, let's just recap what we learned. We learned how to create variables and constants, what we can name them, what sort of things we can store in them, and how we can define what their type is. We also learned a little bit about type inference and type annotations. Next video, we'll dive into the details of the types that Swift gives us and how we can use them in our programs. Thank you for sticking with me, and I hope to see you in the next video. See ya!